Okay, we're talking about fracture, and the last thing we talked about was the concept of stress intensity factor, and eventually the idea is that it will play a critical role in making or characterizing fracture and making use of it in order to calculate whether fracture occurs or not. Still, we're not perhaps entirely clear about what fracture means. We understand that things break apart, but eventually to understand the underlying physical mechanisms that contribute to fracture, I'm doing here a very simple experiment that I sometimes like doing in class. It's one of the simple experiments that we do. And here what I've done is I've taken simple tape, I've adhered onto the surface of my desk. It adheres quite well, but before adhering it, I put some rubber band underneath the tape. That's roughly midway through the length of the tape, which is over here. And when I introduce the band, of course, the tape cannot fully adhere to the surface. The band prevents it from adhering to the surface of the desk, and thereby it sort of introduces a crack, you see, within the interface between the band and the surface of the desk. Okay, and for sure now, when I pull on this band, that presence of the crack is, if you like, is going to introduce some stress concentrations or very high stresses in the vicinity of the crack tip, and the stresses will be less over there with some decay that I don't need to really know exactly, but certainly it does decay towards the end of the band. Okay, so now what I will do is simply I will pull on this band and I will watch what will happen. Now, of course, we can sort of imagine at this stage the final outcome of this experiment when I pull on this band, but really I am interested in the process of reaching that final outcome. So let's go ahead and do this simple experiment. Now, at this point, one thing to watch for, I should emphasize, is the level of my finger, because when I pull on this band, it's going to load the tape, and the amount of force that I apply is proportional to the displacement of the tip of the band, and that is associated with the position of my finger, right? So when my finger moves up, the force will increase, and when my finger does not move anywhere and the tip of the band remains where it is, then the force is a constant. If my finger is fixed and the tip of the band for some reason starts moving up, the force in the band is starting to decrease, right? And also keep in mind something about the concept of strain energy. This is something you covered in ME 231. Strain energy is the total amount of elastic energy that is stored in this band when I pull on it. It's like potential energy. Okay, now let's go ahead and do the experiment, and I will try to demonstrate or point here what you should be looking for. Okay, so now I'm going to start pulling on the band. And now the first thing we recognize is I pulled on the band and nothing fancy happens. Of course, the band gets compressed a little bit, perhaps peels a tiny bit, but the fact that I'm pulling on the band, in other words, the fact that I exert a certain amount of force, doesn't necessarily mean that the band will immediately peel away. It doesn't. Perhaps it peels off a little bit, but not completely, right? Okay, so I am pulling on the band a little bit, it doesn't peel off immediately. I pull on it a little bit more, it still doesn't peel off, right? Not completely. So perhaps a tiny bit due to stress concentrations in the vicinity of the crack tip, it peels a little, but not completely. I keep pulling further. Actually, it turns out you can pull quite a bit. I keep pulling further. I pull further, and still it's not peeling, you see. It's carrying a lot of force. So the fact that there's a stress concentration doesn't mean that this whole structure is going to fail immediately, right? So that's what we can keep in mind for our future fracture discussions. The fact that there's a very large stress in the vicinity of the crack tip doesn't mean the whole thing is going to break up immediately. There will be failure in the vicinity of the crack tip, but not structural failure globally. So now I keep pulling further, and I pull, and I pull. Okay. Now, the force is starting to become quite large. It still has not peeled off completely. Now I'm increasing the force. You can watch the level of my finger. At some point I will start to keep it constant. Okay. I'm pulling still. And now I keep my finger constant. Watch its level. And now also you should watch the position of the tip of the band. Actually, the tip of the band now is moving up. Very slowly, but for sure it moves up. The top of my hand is remaining fixed. The tip of the band is actually slowly moving. Slowly moving. It's going to speed up after a while. We just have to be patient. To accelerate the process, I could have pulled perhaps a little bit more, but I have reached a critical load where the crack is propagating steadily but slowly, right? And the tip of the band is still moving up. You see it moved up slowly but quite a bit already. It's still moving up steadily, and finally it just peeled off completely. Okay, so let me summarize what just happened over there. We used a standard piece of tape and it was adhered to the surface. And I cannot take this band off, so I'll keep it there. I had adhered to the surface and the band was there. I started pulling on the band and the tape did not peel up for a certain while. And when I'm pulling, I am storing elastic energy in this rubber band. I pulled up to a certain level, and after a while, so the strain energy reached its maximum value. What happened was the tip of the band started to move up slowly. Okay, slowly it moved up, and at some point, fracture occurred. Or the tape just peeled off from the surface. Now, the question is the following. Okay, so I'm loading the band and the energy is being stored in the elastic band. But after a while, the tip of the band moves up, although my hand is remaining fixed. The question is, what is happening to the energy that is being released from this band? Because energy is being released. My hand is fixed, the tip of the band is moving up because the tape is peeling off, so energy is being reduced in the system. Well, where's that energy going to? Right? I'm losing energy in the system. The energy must be going somewhere because it should be conserved. The question is, where is it going? Okay? So I'd like you to think about that question a little bit, right? So if you like, pause the video and think about it. Now, let me discuss briefly what is happening. As you might imagine, if I have a piece of band and if I peel it onto the surface, from the surface, I have adhered it, and I'm going to peel it off, I have to apply some force. And because I'm doing a certain amount of force, right, I'm applying a certain amount of force with a certain velocity, force times velocity of pulling is the work that I input to the system. So that's the energy that is being somehow used up by this process. Well, right, where is that energy going to? Where the energy is going to is the following. The tape has adhered to the surface and there is a certain bonding through adhesive forces between the tape and the surface of the desk. And when I'm pulling, with the forces that I generate, I'm breaking those bonds between the tape and the surface of the desk. And that requires work. Technically speaking, what I'm doing is, presently, there is only a perfect interface between the surface of the desk and the elastic band. And when I peel the tape off, I generate a new surface. In fact, I generate two surfaces. One that is associated with the desk, two that is associated with the tape. The interface was perfect. There was a single interface, and now, boom, I generate a new surface. The surface of the tape and the surface of the desk by breaking those bonds. Okay? So whenever you have a perfect interface and you break the bonds at the interface, then you generate new surfaces, and it turns out there is some work and hence energy associated with breaking those bonds. So going back to this question, what is happening is I pull, and there comes a certain point where energy is being released from the system, and that energy is fed into the creation of new surfaces, which has to do with the propagation of the crack. What we have to keep in mind is there's a certain amount of energy that must be stored in the system before the crack can propagate to generate those new surfaces, right? When I say about the crack propagating, I'm talking about the tape peeling off, because as the tape peels off, in some sense, the size of the crack is growing. Initially, it was small. As it grows, as the tape peels off, the size of the crack is increasing. So it's the crack is propagating. So there is a certain amount of critical energy at which the crack starts to self-propagate without additional input from the system. That's the total energy that has already been stored. The crack propagates, and the energy that is needed for the crack to propagate, and as it does so, it creates new surfaces. The energy that is needed comes from the energy that is being already stored in the system. That energy is released and fed into the creation of new surfaces through the propagation of the crack. So let's keep that in mind when we carry out our discussions of fracture.